Example 7. The continuous random variable x has probability density function as follows. Find the value of the constant a. So in order to find the constant a, we need to integrate from negative infinity until infinity for the function and make it equal to 1. So I'm going to draw the number line first and then put up the values of x, which is 0, 1 and 4. 0, 1 and 4. Take note that the value here refer to negative infinity and the value to the right is referred to the positive infinity. And then I'm going to put up the function. Between 0 and 1, the function is ax. Between 1 and 4, it is a over 3, 4 minus x, and then 0 otherwise. I'm going to integrate from negative infinity until infinity. So first of all, integrate from negative infinity until 0, but the function is 0. And then 0 to 1, the function is ax. And then 1 to 4, the function is at a over 3, 4 minus x. And then the last one, 4 until infinity, but the function is 0. And then make it equal to 1. So we know that integrate the 0 function will give us the value of 0. So we just need to integrate ax, which is ax squared over 2, and then substitute 1, 0. And then integrate a over 3 for the function 4 minus x is just a over 3 4x minus x squared over 2, since a over 3 is just the constant, and then make it equal to 1. And then substitute x equal to 1 and also x equal to 0. And for the second part, x equal to 4 and x equal to 1. And don't forget to make it equal to 1. And then calculate the value. From here, we're going to get half a. Here it's going to be a over 3, and then 8 minus 7 over 2 equals to 1. And then calculate it again, and we're going to get 2a equals to 1. So a equals to half. So this is the value of a. To answer for the question B, find the probability from half until 3. I substitute a equals to half into the function, and then I draw the number line. So I'm going to put up half and 3 into the number line. So half should be somewhere here and 3 somewhere over there, and then we're going to find the probability from half until 3. So we can obviously see that we need to separate it into two parts. The first part is integrating from half until 1. The function is half x, and then plus the second part 1 until 3, and the function is 1 over 6 4 minus x, and find the value. Integrate and then find the value. For x squared over 2, and then substitute 3, 1. So half, when we substitute 1 into the x, we're going to get half. When we substitute half into the x, we're going to get 1 over 8. And then substitute 3 into the x, 15 over 2. And then substitute 1 into the x, 7 over 2. So the final answer is 41 over 48. C. Estimate the median. In order to find the median, we need to integrate from negative infinity until the m to get the answer. But since we have two different functions here, we need to check whether the median lies in the first function or the second function. So to check, I'm going to integrate from 0 until half for the first function, which is half x, and then I'm going to check the answer. Substitute, then I get 0.25. Median means total probability equal to 0.5. Since we get the value here is 0.25, it is less than 0.5, thus the median does not lie on this function, which means median lies on the second function. So to find the median, I'm going to write the conclusion first. Median does not lie on this function since total probability less than 0.5. So to find the median, we're going to integrate from 0 until 1 for that function, half x dx, and then plus with 1 until the m, which is the median, since we know that median lies on the second function, so 1 until m, and the function is 1 over 6 4 minus x. And then make it equal to 0.5, since we know that median is equal to 0.5. So here, I'm just going to get the value that we get when we done the checking part, which is 0.25. And then integrate this one here, will give us 4x minus x squared over 2. Substitute mm1, make it equal to 0.5. Then move 0.25 over there to the right, so we have 0.25. Substitute mn1 into the x. Substitute the E1 will give us 7 over 2. 0.25. And then we're going to find the values of m. Six multiply with 0.25, 3 over 2, and then multiply everything by 2. To make sure that we have no denominators, and then make it a quadratic equation. And then find the values by using the calculator, but we're going to get the in points. The values of m is in point, so we're going to use the formula negative b plus minus b square minus 4ac square root divided by 2a. So m equals to 0.25 So m is equal to 6.45 or m equals to 1.55. We need to choose one of these values to get the value of our median. So to choose the correct answer, we check the range. Our median lies between 1 and 4. So the correct value is m equal to 1.55. Make the conclusion. M as in median is 1.55 since the value of median must lie between 1 and 4. D. Find EX and variance 2 minus 3x. The formula for EX or mean or expectation for any continuous random variable is integrate negative infinity until infinity x multiply with the function dx. This is the formula. So from the given function, I already draw the number line. So EX is equal integrating from negative infinity until infinity. So I'm going to start from negative infinity and then stop it at 0. X is just x, multiply with the function which is 0 dx, and then plus integrate from 0 until 1 x, and then multiply with the function half x, and then integrate 1 until 4 for this function, x, and then multiply with this function, and for the last one 4 until infinity, and the function is 0. So x multiply with 0. Then we need to find the value. So integrate x multiplied with 0 is going to be 0, and integrate 0 will give us 0 function, and here also 0. So we just need to integrate these two. Integrating the first one, but then we need to simplify it first. Half x squared, and then simplifying the second one, we're going to get 1 over 6 4x minus x squared, and then integrate grab the value 1 over 6, integrate, put up the value, and then substitute. Substitute. Here it's going to be 103, and then up here 32 over 3 minus 5 over 3. So you're going to end up with 5 over 3. So this is the value for EX. And then we need to find the variant 2 minus 3x. By using the properties, variant 2 minus 3x is equal to variant 2 plus with variant negative 3x. I put the sign plus here to make sure that the value of variant is positive, since variance cannot be negative. And then by using the properties, variant 2 is equal to 0, whereas variant negative 3x, we're going to move up negative 3, but then put it square variant x. So it's just 9 multiplied with variant x. So we need to find the variant x and then multiply it with 9. So the formula for variant x is ex squared minus ex squared, which means 5 over 3 that we found before, we're going to plug in into here. So we just need to find ex squared in order to find the variance. So ex squared, the formula for ex squared is just integrate negative infinity, x squared multiplied with the function. This is the formula, which means it's going to be looking like this, but instead of x, we need to put it x squared. So just the same thing with ex, but then x squared multiply with the function. Sorry, negative infinity 0, then 0, 1, x squared multiply with the function, x squared multiply with the function, x squared multiply with the function. As usual, integrating 0 function will give us 0, and then simplify in order to integrate. Then integrate. And then substitute the value. Here, when we substitute x equal to 1, we're going to get 1 over 4. X equal to 0, we're going to get 0. And here, substitute x equal to 4, we're going to get 64 over 3. And then substitute x equal to 1, we're going to get 13 over 2. So the final answer is 7 over 2. But bear in mind that we need to find the variant 2 minus 3x, which is equal to 9 multiplied with variant x, so the formula for variant x is ex squared, which is 7 over 2, and then minus ex squared, which means 5 over 3 squared. Which will give us the value of 13 over 2.
Now we are going to proceed with the example 8. The question states that x is a continuous random variable with the probability density function. So this is the PDF. With the function fx equals to 1 over ax, where the x varies from 0 until 4. And the question A, for the part A, asks to find the cumulative distribution function. So the question asks to find the CDF, which is, so we can write it in another notation, which is using the capital letter of F. So you have to remember that in order to find out the CDF from the PDF, if you are given the PDF and you want to find the CDF, So what you need to do is you have to integrate. You have to integrate every single function that you are given from the PDF in order to convert it from the to the CDF. Okay, so before that, we are going to split up how many interval we are going to identify how many interval that we have to form in order to find the CDF. So how are you going to do that? Okay, back to the question. Since the question just only give you one non-zero function with the limit from 0 until 4, or you can just write, if we write it in this form, in this interval form, which is, this is from 0 until 4. From 0 until 4 is for the non-zero function, and for the other interval is for the zero function. So from here, we can notice that altogether, we have 1, 2, and 3. Altogether, we have 3 intervals that need to be find out the CDF, the capital letter of fx. So to find the CDF, we're going to write it in the form of table. This is just an optional to make it more systematic. To find out this, to make it your working more systematic. It's just optional to write it in the table. So we're going to start with the first interval. Okay, this is the first interval. So this interval is actually referred to the x less than 0. This is the x less than 0. So how are you going to find the capital letter of fx, or in other words, the CDF? Okay, just remember that to find the to write on the notation for CDF, you need to use the capital letter of f. Okay, equals to, we're going to integrate. Since we're going to find out the CDF, so we're going to integrate from, we're going to start from the negative infinity. We are going to start from negative infinity, integrate until x. We are not going to integrate from until 0, because 0 is the maximum for that interval. Okay, so we are going to write it as x, negative infinity to x. Why we write it as x? X actually representing any value on that range. It means that from negative, it could be negative infinity to negative 1, for example, negative infinity to negative 10. So x is a variable that representing any value from that range, maximum to 0. So that's why we're not going to integrate from negative infinity to 0. It should be until x. So what the function that need to be integrated here? It should be 0, because this is the area where the 0 function. This is a 0 function. So we are going to start, we are going to integrate 0. So since we are going to integrate 0, so then we get 0 function for the first interval. Okay, so for the f of c is actually, we are going to substitute the upper limit for that interval. So this is the upper limit. Okay, this is the upper limit. So this is the value of c. We're going to substitute c into the fx. Since the function of fx here is 0, we're going to substitute 0 into the 0 function, which is f of c will give you 0. Okay, then we're going to proceed with the second interval. Okay, so this is the second interval. Okay, so you have to remember that since this is the cumulative, this is the cumulated function. We are going to accumulate from the starting, which is from the negative infinity and onwards. So write the interval first. So this is the interval for the x varies from 0 until 4. So to write on the function of fx here, it should be f of 0 plus with 0 to x. Okay, 0 to x. Okay, why it should be f of 0? This is the cumulated. We have cumulate from the starting from the negative infinity until until f0. This is the f0. This is the cumulative. So we're going to accumulate from the starting. So before we are entering this interval, we already accumulate from the first interval. The first interval we accumulate for the f0. So for this one, f of 0 plus with integration of 0. So how why we are starting from 0? So this is the starting for the second interval. This is 0. We are going to integrate until x. 0 until x. It's not 4. We are not integrate until the maximum. Okay, we are going to integrate from the starting, which is 0. From the beginning is 0, beginning of that interval, until x. Because x represent any single x for that interval. It could be 0 until 1, it could be 0 until 2, it could be 0 until 3.1, it could be 0 until 3.9, any value of x up to 4. So we're going to substitute what fx should be here. So since this is a non-zero area, which is the function fx is located here, so we are going to integrate 1 over 8 x dx. Okay, so what's the value of f of 0? F of 0 is come from here. Alright, I do some mistake here. It should be f of 0. It's not f of c. It should be f of 0 here. Okay, so f of 0 from the first part, we have find out which is 0. So we are going to equals to 0. So this is a 0 plus with integration of 1 over 8 x. It will be 1 over 8 x squared over 2 with the limit 0 until x. So then, if you simplify it, we substitute, we are going to have 1 over 8 of x squared over 2 minus 0. So that will give you x squared over 16. Okay, that will give you x squared over 16. So then, for the last column, we are going to find out f of 4. Why it should be 4? Because this c is actually your upper limit for that interval. So the upper limit is here is 4. So we're going to find out the f of 4. So how are we going to find out f of 4? So we have to substitute this 4 into this function. This is the fx that we have found out. So you just need to substitute 4. So then we will substitute 4 squared over 16. You get 1 for this part. Okay, and then we're going to substitute for the last interval. This is the last interval. Okay, last interval is for the x greater than 4. It's for x greater than 4. And the function here, it should be fx equals to, since we are starting from, for this interval, we start from 4. We have to integrate from 4 until x. So, but you have to remember that before you entering this third interval, you have accumulate from the starting. So the accumulation from the starting until 4 is referring to the f of 4. So we are going to start with fx equals to f of 4 plus with integrate from 4 until x with the function 0. Okay, why 0? This is the 0 function, because you just only, the question just only give you one non-zero function, which is 4, 0 until 4. Okay, so for the f of 4, we already find out from the previous part, which is this is the f of 4. So we're going to substitute here. This is equals to 1. And for the integration of 0 will give you 0. So at the end, we end up with 1. So that is our target. So in order to find the CDF, you have to remember that, you have to bear in your mind that the last function should be 1. You should end up with 1. So then you just stop. Okay, so that's the final step. Okay, so to write on the final answer should be write on in the form of piecewise. So this is the CDF. Going to write out. Okay, so you just copy down all the interval with the fx, but we start with the fx first. Okay, so this is the first function, which is 0. We are going to write it 0 for x less than 0. And then we're going to start with next, which is x squared over 16 we're going to write on is here x squared over 16 for the x greater or equal than 0, less or equal than 4. And lastly, 1. Okay, it should be 1 ended with 1. So here for the x greater than 4. Okay, we have done for the finding CDF from PDF. Okay, then we are going to proceed with the second part, which is B. The question asks to sketch the graph of y equals to f, capital letter of f. So you must be careful with the notation here. This is the question asks to sketch the graph for the CDF. This is the CDF, not the PDF. Okay, the notation here is referring to the CDF. So it means that we are going to sketch this graph. Okay, we are going to sketch this graph. Right. So back to the fx CDF that we have to find out before that. So altogether we have 3 functions starting from 0, and then the second function continue with the quadratic and end up with constant. So for the quadratic function, okay, we're going to start with the quadratic function. We are going to write it here, fx. I'm going to take out the function x squared over 16. Okay, the minimum here should be 0, 0. And then since the interval is varies from 0 until 4, so we're going to find out these two values. So we're going to calculate to find out the f0 and also f of 4. So f of 0 should be 0 over 16, so equals to 0. So this is the minimum point. It's the same point with the minimum point. So f of 4 equals to 4 squared over 16, which is give you 1. So we're going to sketch the graph. Right, we're going to start with this point. We're going to start with this point, which is 0, 0. Okay, this is the 0, 0. This is a 0, 0. And then end up with 4, 1. So 4, 1. Let's say this is the 4. This is the 1. Okay, I'm going to denote it as just a blank dot, because since this is an included value, 0 and 4 is included. So we're going to start with the black dot, ending with the black dot. Okay. Just connect these 2 points using the curve. Just sketch the curve form. Okay, and then we have settled for the quadratic, and then we are going to proceed with the constant. Okay, fx equals to 1. So this is the constant function from x greater than 4. So we're going to sketch here from 4 and onwards. Okay, just continuously going to the right side. Okay, and then make sure you label the axis. This is the x. This is the capital letter of f. Right, so we have done for the sketching for the CDF function. Okay, the next part, C. Question asks to calculate the probability. This is the probability for x less than 1. So when it comes to continuous random variable, you have to know that for the capital letter of fx, which is the CDF, is equals to the integration of negative infinity to x, the function here fx dx, equivalent also to the probability of x less than x, also equals to for x greater or x less or equal than x. So the things that need to be highlighted here is when it comes to the continuous, okay, it doesn't matter whether it has no equal sign. It just only the sign is just the less sign or less or equal. It doesn't matter whether it has an equal sign or don't have the equal sign, as long as the sign is less than, it's equivalent to the capital letter of fx. Okay, why these two things are equivalent? Why these two things, px less than x, it should be equals to px less or equal than x, because px equals to x equals to 0. Okay, since this is the area that we have to find out, for the x equals to x, it actually doesn't give you any area on that, so that's why it's equivalent. Less than or less or equal is just equivalent. So for this question, since the question asks for the x less than 1, so it's actually equals to px less than 1 equals to the capital letter of 1. Okay, why we convert this into the capital letter of f? Okay, so since from the previous part we have find out the CDF, we have find out the CDF function, we have found out the CDF. We already have the function for the cumulative, so it's better we are using the cumulative function to find out the probability rather than using the PDF. If you are going to use the PDF, you need to integrate. Okay, if you don't have the CDF, you just only the PDF, you have to use this kind of method. You have to integrate. But now the situation is we already have the function of fx. So in a short way, we are going to use this rather than integrate. So how are we going to find the f of 1? So we are going to substitute 1, x equal 1, into the correct function. So what is the correct function? So we are going to go back from the previous part. Okay, here we are going to use this function. Okay, now we are going to substitute the x equals to 1. So we have to find out where is the location of x equals to 1. So x equals to 1 obviously is in between of this interval. X equal 1 is located here. So it means that we are going to substitute 1 into this function. Okay, so back here, so means we are going to substitute into the x squared over 16. So it should be 1 squared over 16. So the answer should be 1 over 16. Okay, so we have settled for the C1. Then we're going to go for the second. This one, x greater or equal than 3 over 2. The sign here, the question asks for the greater. In order to use the capital letter of f, which is the CDF, we have to make some rearrangement. Okay. So since the question asks for the greater, so we can convert it. We can change it. It's equals to, I think I should write here, px greater or equal than 3 over 2 is equivalent to 1 minus px less than 3 over 2. Okay, you have to convert in another way, which is give you the same meaning. So when we change the equation, so then here we get 1 minus, since this is already less than, so we can change 1 minus f of 3 over 2. So then we can use the capital letter of f. So means we are going to use the CDF. We are not going to integrate once again because we have find out the CDF. So then we are going to substitute 3 over 2 into the correct function. So back to our CDF. So 3 over 2 is 1.5. So 1.5 obviously is between 0 to 4. So we are going to substitute into the same function. So 1 minus 3 over 2 squared over 16. Okay, we are going to substitute into this function, x squared over 16, which is for the x greater than 0, less or equal than 4. We're going to substitute into this function. So and then calculate, at the end you will get 55 over 64. Okay, and proceed with next. For this question, ask to find x greater than 2, less or equal than 3. So this is in between of two values. So you can just straight away write down f of 3 minus f of 2. Okay, f of 3 minus f of 2. It should be f of the upper limit minus f of the lower limit. Okay, so and then we're going to substitute 3 and 2 into the correct function. So since 3 and 2 is located in between of 0 and 4 also, so we're going to substitute into the same function. So it should be 3 squared over 16 minus 2 squared over 16. So then calculate and you will get 5 over 16 for the final answer. Okay, lastly, we are going to proceed with the last part for this example, which is find the median. Okay, when it comes to median, everyone should understand that this is the half. So what half for this part, for this questions, right? So since that we should know that the total area for the continuous random variable, okay, so I just copy down here, this is the function. If the total area, let's say from A to B, let's say the function is bounded from A to B, since this is the area. If the total area, since the total area should be 1, when it comes to median means that the value of x. Median is the value of x that cut the area into the half. So means we want to find out half of the area. It should be 0.5 and 0.5. So what's the value of x here? This is the median. So we want to find out this x, which is cut the area into half, the first half and the second half. Okay, so for the notation, we can write it. For the notation, we can write it f of m equals to 0.5. So why is m? It's just an optional. You can write it as fx. Okay, why it's m? M actually refer to the median. Okay, you can just write it f for the fx because m is actually the value of x. Okay, why it should be f, capital letter of f? Because capital letter is referring to the cumulative. We want to cumulate from the beginning until to what value of x, so that the total area should be 0.5. So this is the f of m. Okay, we are going to accumulate from the beginning until what value of x, which is m here, equals to 0.5. Okay, so since we have find out the CDF, we are going to find out the median using the CDF, not the PDF. It's different way. So since we already have the CDF, we're going to use it. Okay, so you have to check, since this question just only have the one function, okay, which is could be locate the x that could give you the 0.5, because the first function already eliminated, because that will give you 0 for any range of this interval. For any x for this interval will give you 0 probability. Means that f -1 equals to 0, f -2 will equals to 0. Any x for this range will give you 0. So it's already eliminated. Okay, for the last function, for this x greater than 4, means that if f5 will equals to 1, f6 will equals to 1, f6.1 will equals to 1. So every single x that greater than 4 will give you 1. We want to find 0.5. We want to find that what value of x that will give you 0.5. So means that the x that we want to find out, it should be in between this range. Okay, the value of x that we have to find out should be in between this range. It should be in between of 0 until 4. It could be 0.1, it could be 0.2, it could be 2, it could be 3, any of x. So means that what we need to do is, we're just going to substitute amp, into this function. Just going to substitute here. So that will give you m squared over 16 equal to 0.5. So I'm going to solve it. So m squared equals to 8. So that will give you m equals to plus minus set of 8, which is set of 8 will give you 2 set 2. Okay, so now we have two possibility of m, whether it is positive 2 set 2 or negative 2 set 2. So since m should be in between this range, m should be between of 0 to 4, therefore the acceptable m here should be positive 2 set 2. The negative 2 set 2 should be rejected because it's out of the range.